I am Gayatri, working as assistant professor in SNS College of Technology. Today I am going to discuss about the topic junction field effect transistors, their features, their construction and working principle, and what are the characteristics in the JFET. And at the end of the presentation we are going to discuss about the advantages, disadvantages and applications. And in between the presentation there will be activity. At last the assessment questions will be there based upon the topic discussed. And the JFET will be comes under the unit 1 transistor and their application, which was studied by first year second semester students for the subject circuit analysis and devices. We are going to discuss about the introduction part of the junction field effect transistor, their features, their construction and the working principle followed in the JFET and the characteristics. It is having the drain characteristics and transfer characteristics. And last we are going to discuss about advantage, disadvantage and applications. First, the introduction part, the name, the represent JFET, which is junction field effect transistor. The transistor basically it is having a 3 terminal. The same as a transistor, JFET is also having a 3 terminal. It is also a semiconductor device, but the JFET, which is a voltage control device, unlike the bipolar junction transistor, which is a current controlled device. Mostly the JFET junction field effect transistor, it is having 3 terminal, which is source, drain and gate. The gate voltage will be when the gate voltage is flowing through the terminal gate, and the flow of the current will be from source to drain terminal. When we are applying the voltage to the gate terminal, the current will be the flow of current will be controlled between source to drain terminal. Unlike for JFET junction field effect transistor, which is used as switch as well as amplifier for in applications. Coming to the symbol, the JFET, it is basically classified into two types, which is a P-channel JFET and N-channel JFET, and it is having a 3-terminal gate, drain and source. The difference between P-channel and N-channel is that the P-channel, the gate, the arrow mark will be outwards. In N-channel, the gate, the flow of voltage will be towards. So, the arrow mark is given towards. And then coming to the features of JFET, it is a voltage control device. The gate voltage will be controlled. Controls the current flowing from the source terminal to the drain terminal, and it is a unipolar device. Either the electrons will be flowing from source to drain, or holes may be flowing from source to drain, where depends upon the gate voltage. So, and also it is having the low power dissipation. The JFET, it is having low power dissipation compared to JMOSFET, the BJT. Available in two channels, which is N channel and P channel configuration. In the N channel configurations, electrons will be the majority, and P channel, the P represents the majority, represents holes. So the majority carriers will be holes in the P channel configuration. And coming to the construction part of N-channel JFET, in the N-channel JFET, the N-channel will be placed, and N-type material semiconductor is placed, and P-type material will be lightly doped in the N-channel JFET. In the P terminal, the gate terminal is taken out, and the N channel, the upper end will be having drain terminal and lower end will be having source terminal. In the P channel JFET, we are taking the P type bar, and N type bar will be placed in between. In the N type bar, the gate terminal will be taken out. In the P channel, in the upper end, the drain terminal will be taken out. In the lower end, the source terminal will be there. In between the N-type bar, the channel is placed. The gate voltage can be controlled by with the help of the width of the channel, and the current will be flowing from drain to source terminal. Coming to the working part, the first we have to consider the semiconductor channel. In JFET, it consists of N-type channel or P-type channel in between the source terminal and drain terminal, and there is a PN junctions. The two PN junctions are formed on either side of the channel, and it is creating the depletion layer between these channels. And the gate voltage, applying the voltage to the gate terminal, the width of the depletion layer will be affected. When the width of the depletion layer will be affected, the electrons will be moving from drain to source in a N-type channel, and holes will be moving in the P-type channel. And depletion layer and channel width, in a reverse bias voltage, at the reverse bias voltage, when we are giving the reverse bias voltage to the gate terminal, the depletion layer will be widens, and affecting and reducing the current flow from the source to drain, and controlling the current. Fifth point, controlling the current. The applied gate voltage thus controls the current flow between the source to drain terminal. This is why the JFET is also called as voltage controlled devices. And coming to working of N channel, in the gate terminal and source terminal, the gate terminal is negative with respect to source terminal, and comparing to drain and source, the drain terminal is positive with respect to source terminal. When we are giving the gate voltage VGS, when the VGS is equal to 0, the lower amount of current will be flowing from drain to source terminal. When we are keep on increasing our VGS value, the depletion layer will be formed in between P and N, and the electrons will be moving from drain terminal to source terminal. When the electrons is moving from drain to source, the drain current will be produced. And coming to P channel JFET, the gate terminal is positive with respect to source, and same the drain terminal is negative with respect to source. When we are giving increasing the gate voltage, the holes will be, that is P type bar, the majority carriers will be holes. The holes will be moving from source terminal to drain terminal. So when the holes is moving from source to drain, the drain current will be produced. Come back to the classroom activity. Can anyone able to find the hidden paintbrush in 8 seconds in the picture? It is placed here. Then discussing about the characteristics, in the JFET there will be having two characteristics. First one will be a drain or output characteristics, and second one will be transfer characteristics. And the drain characteristics will be plotted with respect to VDS and with respect to drain current. When VGS is equal to 0, the drain, there will be three regions. First one region will be saturation region, and active region, and breakdown region. In the active region, the drain current will be becomes constant. Breakdown region, when we are increasing the voltage, the breakdown region breakdown will occurs. Then coming to uh, uh, transfer characteristics. The transfer characteristics is drawn between VDS and ID, drain current. It can be determined by keeping VDS as constant. And drain current can be observed by changing the gate source voltage. The transfer characteristics is just opposite to the drain characteristics. Coming to advantages, it is stability, low power consumption, it is having simplicity compared to other transistor, and also it is having a high impedance, so it is used in amplifier circuit. Disadvantages, it is a unipolar device, and also it is having gate to source leakage, and low gain will be there, and limited availability, and also cost is high. Applications, it is used in low noise amplifier, switching circuits, sample and hold circuits, voltage regulators, and oscillators. And at last, discussing about the assessment question. JFET is a voltage control device. Yes, it is a voltage control device. Which of the following statement is true about JFET? It is having high input impedance. For N-channel JFET, what is the direction of current flow? It is from drain to source. Thank you.